Hi everyone, and welcome to this walkthrough on portfolio optimization using Python. In this video, I'll show you how to build a comprehensive portfolio optimization tool that includes data collection, risk and return recalculations, efficient frontier visualization, optimal portfolio weight calculation, and performance comparison with the benchmark. Let's dive into the code. So first, I import the necessary libraries, YFinance for downloading financial data, Pandas and NumPy for data manipulation, Matplotlib for plotting, and the minimize function from SciPy for optimization. I define a list of stock tickers, Apple, Microsoft, Google, Amazon, Tesla, and set the S&P 500 as our benchmark. I also set our date range from January 1st, 2023 to January 1st, 2024. I download the adjusted closing prices for both the stocks and the benchmark using YFinance. Then I drop any rows with missing data to ensure a clean data set. Next, I separate the portfolio data, our stocks, from the benchmark data to analyze returns. I calculate the daily log returns for both the portfolio and the benchmark. Log returns are used because they have a properties that make sure that further analysis is easier. Now that I have our returns, I calculate an expected annual returns by taking the mean of the daily log returns and multiplying by 252, which is the approximate number of trading days in a year. I also compute the covariance matrix of the daily returns and analyze it by multiplying by 252. The covariance matrix is essential for measuring the risk in our portfolio. I print both the expected annual returns and the analyzed covariance metrics to review our risk and return estimates. To visualize our efficient frontier, I simulate 10,000 random portfolios. For each portfolio, I randomly generate weights that sum to 1. For each simulated portfolio, I calculate the expected portfolio return, its volatility, and the Sharpe ratio. Here the Sharpe ratio is computed as the portfolio return divided by its volatility, assuming a zero risk-free rate. I store these metrics and then plot them on a scatter plot. The x-axis represents volatility, the y-axis the expected return, and the color indicates the Sharpe ratio. The visual helps us understand the risk-return trade-off for different portfolio weightings. Next, I move on to calculating the optimal portfolio. I define a function that computes the negative Sharpe ratio because we want to maximize the Sharpe ratio, but our optimizer minimizes functions. I also set up a constraint that the sum of all portfolio weights must be equal to 1. I'll provide an initial equal weights as the start guess using SLSQP method from SciPy optimize. I minimize the negative Sharpe ratio. Subject to our bounds and constraints, the output gives us the optimal weights for each stock in our portfolio. I print out these optimal weights and then calculate the optimal portfolio's expected return, volatility, Sharpe ratio, which are key metrics for our portfolio. Finally, I compare the performance of our optimized portfolio to that of the benchmark, which is the S&P 500 in this case. I calculate the portfolio's daily returns by making a weighted sum of the individual stock returns using the optimal weights we computed earlier. And then I compute the cumulative returns for both the portfolio and the benchmark. Cumulative return shows the growth of a $1 investment over the period. I plot the cumulative returns for both of our optimized portfolio and the benchmark on the same chart to compare their performance over time. This comparison helps us evaluate if our optimized portfolio outperformed the broader market index. So then we scroll down. We have our expected annual returns, and then we have our annualized covariance metrics, and then we simulate random portfolios for an efficient frontier, and then here we see the color signifies Sharpe ratio, x-axis is volatility, which is standard deviation, and then we have our y-axis, which is expected return. All right, and then we scroll down, and we go to find, and then we have our Sharpe ratio portfolio, And then we have our optimal portfolio return. And then we have the optimal portfolio mortality, as well as the optimal portfolio Sharpe ratio. And then we can see here that our optimized portfolio had significantly higher cumulative returns compared to our benchmark, which was the S&P 500 in this case. So, and then we had a little and then makes it just says portfolio optimization completed successfully. So, in summary, this script demonstrates a full pipeline from portfolio optimization, from data collection and risk return calculations to visualizing the efficient frontier, finding the optimal weights, and finally comparing the portfolio performance with a benchmark index. This approach is crucial for investors looking to balance risk and return efficiently. Thank you for watching, and I hope you found this walkthrough insightful.